Okay, the final example today, absolute maximum and minimum of f of x equals the square root of 3 sine of x minus cosine of x on the interval 0 to pi. So again, we got our three criteria. 1, 2, 3. Criteria 3 is the easy one. Endpoints, so 0 and pi are automatically critical numbers. X equals 0, comma pi. For the remaining ones, we need a derivative. So if I go f prime of x equals, now keep in mind, the square root of 3 is just a number being multiplied by sine of x. The derivative of sine of x is cosine of x, so the square root of 3 just comes along for the ride. It has no bearing on the actual derivative. Okay. The derivative of cosine of x is negative sine of x, so it's minus cosine, so it's plus sine. Alright, so the first derivative is the square root of 3 cosine of x plus sine of x, and we have two criteria to meet. Let's worry about number 2 first, because that's easy. Cosine and sine are never undefined, right? So, empty set, there's no critical numbers off of that one. As far as equaling 0, this is actually pretty challenging. Square root of 3 cosine of x plus sine of x equals 0 is not something that can be solved algebraically because I need these to be the same trig function. They're different trig functions. So the way I need to do this is I need to go to my calculator and graph it and find out where it crosses the x-axis, because this stuff equals 0, where it equals 0 is where it crosses the x-axis. So I'm going to type in my calculator square root of 3, make sure the end parentheses occurs, square root of 3 end parentheses, and then cosine of x is outside the radical, end parentheses, plus sine of x, end parentheses. So again, every one of these functions has a beginning parentheses on them. Make sure the end parentheses happens where the function ends. Square root of 3 is only the square root of 3. Cosine of x is only cosine of x, like that. As far as the window is concerned, the x numbers I care about are between 0 and pi, so I'm going to set my window for x from 0 to pi. And all I care about is where it equals 0, so I want my y min and max to be near 0, but I'm going to go negative 2 to 2, probably big enough. I don't have to see the whole graph, I just have to see where it crosses the x-axis. Hit graph, see what happens. Oh, you know what, I think I'm in degrees. Pretty sure I'm in degrees. I'm pretty sure it's supposed to be a little more curvy than that. Let me get out of here, go to my mode, and hey, I'm not in radians. Remember in calculus we're always in radians. Hit graph again, see what happens. Oh look, that's curvier. Oh wow, I just made it big enough, didn't I? Again, it doesn't really matter if I can see the top of the graph or not. What matters to me is this point where it crosses the x-axis. Looks to be a little bit larger than 2. 1, 2, 3, right? So if I do a calculate the 0, and I'm going to put a left bound 2, which is smaller than the answer, right bound to 3, which is bigger than the answer, I can see very clearly the answer lies between those. I'm going to guess 2.1. We get 2.0943, so 2.09. If you got a good eye for this thing, you might notice that as 2 pi over 3. Okay, look at that. If you happen to get the exact value, fine. Just know there's no real easy algebraic way to solve that to get that. So again, the decimal approximation is fine as far as I'm concerned. So I got critical numbers now of 2.0901 pi. So again, what I want to do is evaluate f of 2.09, f of 0, and f of pi. My function that I'm evaluating is that function. So I go back here, I've got the derivative typed in, but this is what I need to have typed in. Since the derivative and the function itself are so similar to each other, I can probably just overtype, verify that I got it typed in right. Square root of 3, end parentheses, sine of x minus cosine, yeah, that's all good. Go to my table, delete my numbers that I got here, got my new critical numbers. 2.09 and 0 and pi. And 2, negative 1, 1. Friendly answers. Alright, so 2, negative 1, 1, is it really 2? 1.9999. Yeah, close enough. I bet you if I put 2 pi over 3, it'll be exactly 2. 2 pi divided by 3. Yeah, exactly. Okay. Alright. Anyway, but that's neither here nor there. All right, so looking at the three results, that's the biggest, that's the smallest. Those are the two that matter. The one is a local, whatever it is, right? Minimum or maximum, but it's not asking for that, it's just asked for absolute. So, absolute maximum of 2 at x equals 2.09, absolute minimum of -1 at x equals 0. Always give me the answers like that. Absolute value, absolute minimum of the y value at the x value. So make sure you write your answers like that. Again, feel free to abbreviate absolute max, absolute min. That's fine with me. Just make sure you give me the right numerical values for them.